In healthcare, the accuracy of a model on unseen data is indeed critical because it reflects the model's real-world performance and reliability. Please subscribe to the channel and share it with your friends. Author's video and white paper on AI engines. Pradeep K. Suri. Author, researcher, and AI-DNN architect. Book for your library. Scan QR code, bookstore in the cloud. When deploying a machine learning model for medical diagnosis or treatment recommendations, the stakes are high, and the consequences of errors can be significant. Therefore, it's important to aim for the highest possible accuracy and to communicate the model's performance in a way that reflects its reliability and limitations. Considerations for unseen data accuracy in healthcare. 1. Reliability and trust. Clinicians and patients need to trust the model. High accuracy on unseen data helps build this trust, but it's also crucial to communicate the uncertainty and limitations clearly. 2. Error rates. Even with high accuracy, the model should be evaluated based on error rates, including false positives and false negatives. For instance, in diagnosing a disease, false negatives, missing a diagnosis, might be more critical than false positives, incorrectly diagnosing a disease. 3. Model validation. Continuous validation using real-world data and post-deployment monitoring is essential to ensure the model maintains its performance over time. Example of communicating model performance. Instead of stating the model has 95% accuracy, you might communicate the performance like this. Overall accuracy. The model has an overall accuracy of 95% on our test data, meaning it correctly identifies 95 out of 100 cases on average. Sensitivity. Recall the model's sensitivity is 92%, indicating it correctly identifies 92 out of 100 patients who have the condition. Specificity. The model's specificity is 97%, meaning it correctly identifies 97 out of 100 patients who do not have the condition. Precision. The model's precision is 90%, so when it predicts a condition, it is correct 90% of the time. Continuous monitoring and updating. To ensure the model remains accurate and reliable in real-world scenarios, continuous monitoring and updating are necessary. This includes 1. Regular re-evaluation. Periodically re-evaluate the model with new data to check for performance degradation. 2. Post-deployment validation. Collect feedback from clinical use and compare model predictions with actual outcomes. 3. Adaptive learning. Implement mechanisms for the model to learn from new data and improve over time. Handling model limitations. Even with high accuracy, no model is perfect. It's important to have protocols for handling model limitations. 1. Human in the loop. Ensure that clinicians review and validate model predictions, particularly in critical cases. 2. Explainability. Provide explanations for model predictions to help clinicians understand and trust the model's decision-making process. 3. Backup plans. Have contingency plans in place for handling model errors, including second opinions or additional tests. Example scenario. If a healthcare model for diagnosing a disease has an overall accuracy of 95% on unseen data, communicate clearly, our model has been tested rigorously and shows a 95% accuracy in identifying the disease based on historical data. However, it is important to understand that this means it could miss 5 out of 100 cases or incorrectly identify 5 out of 100 healthy individuals as having the disease. Emphasize continuous improvement. We continuously monitor the model's performance and update it with new data to improve its accuracy and reliability. Practical considerations. Accuracy metrics. Use comprehensive metrics like AUC-ROC, F1 score, sensitivity, specificity, and precision to give a full picture of model performance. Interdisciplinary collaboration. Work closely with healthcare professionals to ensure the model meets clinical needs and integrates well with existing workflows. Regulatory compliance. Ensure the model complies with healthcare regulations and standards for safety and efficacy. By taking these steps, you can ensure that your healthcare model not only achieves high accuracy but also provides reliable, trustworthy, and actionable insights for patient care. Increasing the size of the testing dataset can have significant implications for the performance evaluation and generalizability of a machine learning model, particularly in critical fields like healthcare. Here's a detailed look at what happens when you increase the size of the testing dataset. Benefits of increasing the testing dataset. 1. Improved estimate of model performance. Reduced variance. A larger testing dataset reduces the variance in performance metrics, providing a more stable and reliable estimate of the model's true performance. Better generalization. It allows for a more accurate assessment of the model's ability to generalize to new, unseen data, as it includes a wider variety of samples. 2. Detection of overfitting. A larger testing dataset can more effectively reveal if the model is overfitting to the training data by showing discrepancies between training and testing accuracy. 3. Enhanced reliability. With more data points, the evaluation metrics, such as accuracy, precision, recall, and AUC-ROC, become more reliable and reflective of real-world performance. 4. Identification of rare cases. In healthcare, where certain conditions might be rare, a larger testing dataset increases the chances of including such rare cases, providing a better evaluation of the model's performance across all possible scenarios. Considerations when increasing the testing dataset. 1. Quality of data. Ensure the additional testing data is representative and of high quality. Poor quality or unrepresentative data can lead to misleading performance metrics. 2. Class imbalance. Address any class imbalances that may arise. For instance, if a disease is rare, ensure that the increased dataset still contains a sufficient number of positive cases for meaningful evaluation. 3. Computational resources. Larger datasets require more computational resources for processing and evaluation. Ensure you have the necessary infrastructure to handle the increased data volume. Example scenarios. Scenario 1, Initial evaluation. Training dataset size, 1000 samples. Initial testing dataset size, 200 samples. Accuracy. Training, 95%. Testing, 90%. Scenario 2, Increased testing dataset. Training dataset size, 1000 samples. Increased testing dataset size, 1000 samples. Expected impact. Reduced overfitting detection, more robust detection of overfitting. If the initial accuracy difference was due to overfitting, the larger test set might show a bigger drop. Stability of metrics, performance metrics, accuracy, precision, recall, etc., will be more stable and reflective of true model performance. Example performance. Training accuracy, 95%. Testing accuracy, 88%, more accurate reflection of generalization. Practical steps for increasing testing dataset. 1. Data collection. Collect more real-world data, ensuring it covers various scenarios and patient demographics. Use data augmentation techniques where applicable, example generating synthetic data that resembles real data. 2. Data splitting. Use stratified sampling to ensure that the increased testing dataset maintains the same class distribution as the original dataset. 3. Evaluation metrics. Evaluate using multiple metrics to get a comprehensive understanding of model performance. For healthcare, metrics like sensitivity, recall, specificity, precision, F1 score, and AUC-ROC are critical. 4. Regular monitoring. Continuously monitor the model's performance as more data is added, and retrain the model periodically to incorporate new patterns and improve accuracy. Conclusion. Increasing the size of the testing dataset is beneficial for obtaining a more accurate and reliable estimate of a model's performance. In healthcare, where decisions can have significant consequences, ensuring the model is well evaluated and generalizes effectively to unseen data is crucial. By following best practices in data collection, splitting, and evaluation, you can enhance the robustness and reliability of your machine learning models. Regular monitoring and continuous improvement are key to ensuring that an AI engine, especially in healthcare, remains accurate, reliable, and effective over time. Here's how regular monitoring and improvement can help enhance the AI engine's forecasting capabilities. Regular monitoring. 1. Performance tracking. Continuously track the performance of the AI engine on new, unseen data. Use various metrics such as accuracy, precision, recall, F1 score, and AUC-ROC to get a comprehensive view of how the model is performing. 2. Detecting drift. Monitor for data drift and concept drift. Data drift occurs when the statistical properties of the input data change over time, while concept drift happens when the relationship between input data and the target variable changes. Regularly comparing current performance metrics to historical ones can help detect these drifts. 3. Feedback loop. Implement a feedback loop where the AI engine's predictions are compared against real-world outcomes. This feedback can be used to identify areas where the model may be underperforming or making systematic errors. Continuous improvement. 1. Retraining. Periodically retrain the model with the latest data to ensure it remains up to date with current trends and patterns. This is particularly important in healthcare, where medical knowledge and patient demographics can change over time. 2. Hyperparameter tuning. Regularly tune hyperparameters to optimize model performance. As new data becomes available, the optimal settings for hyperparameters may change. 3. Feature engineering. Continuously explore and incorporate new features that could improve the model's performance. This may involve domain-specific knowledge, such as new medical indicators or patient history data. 4. Model selection. Experiment with different model architectures and algorithms. Sometimes newer or more sophisticated models can offer better performance. 5. Validation and testing. Continuously validate the model using cross-validation techniques and maintain a robust testing framework to ensure that improvements are genuine and not overfitting artifacts. Practical steps. 1. Set up monitoring tools. Use tools and platforms designed for model monitoring, such as MLflow, Prometheus, or custom dashboards that track performance metrics over time. 2. Automate retraining pipelines. Set up automated pipelines for data collection, pre-processing, model training, and deployment. Tools like Apache Airflow or Kubernetes can help automate these processes. 3. Incorporate domain expertise. Collaborate with healthcare professionals to continuously improve the model. Their insights can help identify important features, validate model outputs, and suggest areas for improvement. 4. Ethical considerations. Ensure that the model is not only accurate but also fair and unbiased. Regularly check for biases in the data and predictions, and take steps to mitigate them. 5. Documentation and transparency. Maintain thorough documentation of the model's development, changes, and performance over time. This transparency helps build trust with stakeholders and facilitates troubleshooting and improvement efforts. Example workflow. 1. Data collection. Collect new data from clinical practice, ensuring it is representative and high quality. 2. Performance evaluation. Evaluate the current model on the new data. Track metrics such as accuracy, precision, recall, and AUC-ROC. 3. Identify gaps. Identify any performance gaps or areas where the model is underperforming. Look for patterns in errors or misclassifications. 4. Model improvement. Update the model by incorporating new features, tuning hyperparameters, or selecting a different algorithm. 5. Retraining. Retrain the model with the new data and improvements. Validate using cross-validation and test on a separate validation set. 6. Deployment. Deploy the updated model to production. Monitor its performance continuously and gather feedback from its use in practice. By following these steps and maintaining a cycle of regular monitoring and improvement, the AI engine's forecasting capabilities will not only improve but also adapt to new challenges and changes in the data, ultimately leading to better and more reliable outcomes in healthcare. Conclusion. Just like human learning and growing over time, an AI engine in healthcare, or any other field, benefits from continuous monitoring, feedback, and improvement. By constantly updating its knowledge base and refining its algorithms, the AI engine can become more accurate, reliable, and useful, ultimately leading to better outcomes and more informed decision-making. This process of continuous learning and adaptation is essential for maintaining the relevance and effectiveness of AI systems in dynamic and complex environments. The accuracy of the AI engine is a critical factor to consider before auditing it. Here's why. Audit focus. An audit aims to assess the AI engine's performance and ensure it's functioning as intended. Without understanding its accuracy, it's difficult to judge its effectiveness. Identifying issues, audits can uncover biases, errors, or inconsistencies in the AI engine's outputs. Knowing its accuracy helps pinpoint areas needing improvement. Setting benchmarks, accuracy benchmarks are crucial for evaluating the AI engine's performance. An audit without such benchmarks wouldn't have a clear basis for judgment. Here are some additional points to consider. Types of accuracy. Accuracy can vary depending on the AI engine's purpose. For example, an image recognition engine might be judged on its ability to correctly identify objects, while a fraud detection engine might be evaluated on its ability to catch anomalies. Data dependence. As discussed earlier, the accuracy of an AI engine is heavily tied to the quality of its training data. The audit should consider how well the data represents real-world scenarios. Transparency and explainability. For effective auditing, it's important to understand how the AI engine arrives at its conclusions. If the decision-making process is a black box, auditing accuracy becomes much harder. In conclusion, accuracy is the foundation for a successful AI engine audit. By evaluating how well the engine performs its intended task, you can identify areas for improvement and ensure it's delivering reliable results. Thank you.